Hello everyone, I'm Adam. In this problem, we're going to be finding our inclination angle theta in both radians and degrees of the line that passes through our 2 points, given here as square root of 3, 2, and 0, 1. So how do we get started? Well, we know that we have a relationship between the slope of a line going through 2 points, m, and the inclination, where m is equal to the tangent of the inclination theta. So all we really need to do is find m, the slope, and then we can use this to solve for what theta is. So what is m? Well, back from algebra, slope m can be written as our, say, y2 minus y1 over x2 minus x1. So looking at our 2 points, again, labeling doesn't really matter which comes first or second. We'll just go from left to right. So this is our x1 and our y1, and here's our x2 and our y2. So down here, our slope, y2 minus y1, or 1 minus 2, and x2 minus x1, 0 minus the square root of 3. So 1 minus 2 gives us negative 1 over negative, say, square root of 3. Negatives cancel, and so our slope is 1 over, say, the square root of 3. So let's label this again. So our slope is 1 over, say, the square root of 3. Now that's positive, okay? So that tells us from our equation here, which normal if you wanted to find theta, we take tangent inverse of both sides. But this is going to be equal to, or theta will be tangent inverse of just the slope m. If our slope was negative, we'd have to add a pi to that as well. But right now it's just tangent inverse of m, which is tangent inverse of our slope 1 over the square root of 3. So tangent inverse of 1 over square root of 3, tangent of what angle gives us 1 over the square root of 3? Well, that's, say, pi over 6, at least right now in radians. So let's put it all together here. So our angle theta is going to be pi over 6, say, radians, and we also want that in degrees. So pi over 6 is also equal to, say, 30 degrees. So there's our inclination in both radians and degrees. There we go. Thank you very much.